All right, I think we should get back underway. We still have pretty much all the people, so hopefully we've not lost too many, and those that are apparently here are actually here and listening. So welcome back from our break. I'm now going to put my Libatomprobe hat on and talk to you about the C++ library that Dan Haley has developed and that I'm also a co-author on. So what is Libatomprobe? It's an open source library for general purpose atom probe computation. So what does that mean? It means we have lots of different algorithms, and these are these are all standard. We only implement things which are published. Different algorithms for doing, say, statistics, for doing file input and output, peak overlap solving, various different things. And the idea here is that with a fairly permissive open source license, you can take this library and use it in as a fundamental building block in your code and applications. So we want the code to be robust. Most of our functions are covered by our unit testing, automated testing. And this maximizes the reliability and accuracy of the code, so you know that it's correct. We try to parallelize things as much as possible on the local PC so that you get the best performance from the code, and it's written in C++, so it's nice and fast. And it's documented, and I'll mention that at the end. So the idea is that this is aimed at people with more coding knowledge than just say average PC user, but a lot of scientists develop their own code, and we're looking to optimize and take away some of the the tedium and the difficulty in reinventing the wheel that happens when people re-implement common functions. For example, anyone who's written a RRNG range file reader will know the headaches that you can have. So we've got code in a standard library that you can use. It compiles on Linux, Mac, and Windows. On Windows, we're using either Cygwin or the Windows subsystem for Windows subsystem for Linux. You can clone the repository. It's fairly straightforward to compile. I'm not an expert at actually compiling things, and I found it relatively straightforward. You can also use it with Python, so you can use all of the power of the Atomprobe library and basically just plug that into Python and use it interactively rather than having to compile C++ code. Currently, this is mainly Dan Haley's work, but also mine. But we're looking for anyone who wants to contribute, and we'd really like to try and make this a part of a lot more sort of general purpose Atomprobe software as broadly as possible. So it implements a lot of existing algorithms, like I said, parallelized and optimized code. This doesn't stop you from using your own code and doing your own analysis. So ideally, you wouldn't even know really you were using Libatomprobe. It would just be something you can use on the background. Whenever you need to open a new file format that's come out, we can implement that, and you can just call open file or whatever, and then Libatomprobe would handle that and spit out the same formatted data that you would be expecting opening a POS file or an ePOS file. It's open source, so you can always see exactly what's going on, and you can check the consistency of the code and look for bugs and check exactly how the algorithm is working. It's C++, so it's very portable. There's no need for, say, a specific graphics card to run some particular algorithm. Any desktop or laptop will do. And we'd be very, like I said, we'd be very welcome for anyone to contribute, especially if you just want to add in a small module. That's very simple to add in, and that's how I started contributing to this project. So we'd be really keen to have people do that. We've got a little live demo of how this works in Python. So we just simply import Atomprobe, and now we've loaded up the library. We can make a vector of ion hits. This is how we store the data. You see, initially it's got 0 length. Now, if we load some random file that doesn't exist, we get an error code, and we can decode that to get the fact that this file doesn't exist. We can open a real file and load some ions. And we can set an output vector of ions And what we're going to do now is just loop over all the ions that we've loaded and crop those based on their X position. So if they have X greater than 0, then we're going to add them to our output vector. And now we're just going to save that vector of ion hits as a TAPSIN binary file. So it's a very straightforward example of showing how you can use the library and how you can say, do, in this case, quite simple operations, but you have the power of all of the data and any of the operations that you'd like to perform. So just to give you a comparison of how it would look in C++ or Python, in C++, you would write C++ code. This could be part of a larger application or just a small, simple kind of app that you want to write. It doesn't have to be very big. And the blue code here between Python and C++ are the library-specific things. So that's what you need to know from the library in order to use it. And in Python, like we showed, it's very straightforward. You just import Libatomprobe, then you use these language-specific bindings in Python, and this gives you Python-typed variables, which you can use however you want in native Python or with any, with pandas or NumPy, whatever you want to do with that. So we enable you to get the data. You can use the library functions if you wanted to do spatial analysis or even reconstruction or whatever it was you wanted to do. But then you've also got all of the power of Python to execute as well and leverage. And all of this is documented with our sort of automatically generated Doxygen files, which I'm showing on the right-hand side here. It's easy to search through. This is automatically generated from the code, so we know that it's up to date. We have various different examples, 15 C++ examples and 10 Python examples, including proxygrams, isosurfaces, correlation histograms, overlap solving. So there's lots of example code that you can just copy and paste, modify as much as you need. And previously we've done online tutorials, and it would be great if there was enough demand for us to do that again. So in summary, we're looking to expand the algorithms that are available. For example, integrating this better with 3Depict so it can use Libatomprobe directly. We'd like to support more languages, for example, R, and I think we've seen there's quite a lot of momentum for R, or Octave or MATLAB. It's possible to do that. And if there's demand, then we'd like to do that. For example, I'm looking to merge the code from Atomprobe Lab, which is my own MATLAB code, into Libatomprobe, specifically say that peak overlap solving and maximum likelihood estimation, that's being ported into Libatomprobe. So that's kind of hopefully going to give that code a new lease of life and allow it to be used more widely. And yeah, with that, I'd like to welcome any questions. I will now look over at the questions and see what questions there are.
Yeah, thank you, Andy, for this great talk and initiative, and also update on your two recent work. There are at the moment no questions in the chat. So are there specific questions to the tools that Daniel and Andy have been put forward and explained?
Everyone's still on their break.
Yeah, I have a question.
Yeah, Peter, go
ahead. So Andy, obviously, so as far as I've seen, everything's command line. So what do you do with cases where user interaction, graphical user interaction is needed?
Mm-hmm. So Libatomprobe is meant to be that kind of basic building block that you could call in a larger application. So we're not imagining really that someone would use Libatomprobe directly. So the Python example shows how you could integrate Libatomprobe use in a larger Python application that you were working on, or as part of your Python toolchain. I've used it, for example, where I've written my own interface, but the kind of back-end computation is all done using Libatomprobe. 3Depict is Dan Haley's Atomprobe visualization software. That's using a lot of common code, even if it's not using Libatomprobe directly. So in the future, I think Dan's plan is to try and integrate those closer, so it is directly dependent on Libatomprobe.
Okay, there's a question from Deodata Schinde. Do you have recorded videos for the online tutorial you have conducted in the past?
That is a good question. I will have to defer to Dan for the answer to that.
Thanks, Andy. Unfortunately, we don't actually have a recorded video of that one. We did attempt to record it, but unfortunately the video ended up being corrupted at the end of that, and I didn't notice until the end. But if there's specific features or modules that people want us to do some pre-recorded videos, we can do this and make them available. Really, because it's quite broad, the sort of how do we focus and narrow down exactly what the community needs is an open question for us.
Yeah, exactly. Okay, I think with that, Marcus, we should move on to.
Ask a quick question, Andy. It's Tim from Kamika.
Yeah, go ahead, Tim.
How are you licensing Libatomprobe? Is it something that we could use and distribute with
Right, so
Libatomprobe suite?
Yeah, so it's a GPL3 license, which means you're not allowed to sell it, but otherwise it's pretty permissible. So I think that you'd be able to use use it as part of a third-party add-on that was available for people to download and use.
Specifically, it'd be helpful, and especially if you had a lot of various file format support, maybe would be the best way for us to include support for all sorts of other people's formats.
Yeah, that's a good idea.
Okay, thank you.
Okay,
Just
sorry.
briefly to add on to Tim's question. So I think there's nothing that's stopping users from being able to directly access that as part of their, I guess, APT 6 call. There might be some technical things that need to be tested just to make sure that all works smoothly. But I think distributing it as a side thing that you don't directly link to, there would be no issues with that. And I'll run that. Well, actually, Andy, do you want to run through this question from Ben Kaplan about the Libatomprobe?
Does it currently have time of flight analysis and algorithm things, voltage and ball corrections? Does it function more on POS type information? That's the right question, Dan.
Yeah.
Yes, at the moment, Libatomprobe is primarily focused, I think, on the POS type information, but it does have the capability of reading in that kind of raw data if you have it available in a format that Libatomprobe can open. So, for example, we're not able to open proprietary software formats from Kamika, for example. I think voltage ball correction, we don't have anything, if that's right, Dan. I know I've done my own thing in MATLAB. It can be relatively straightforward. It depends precisely how you want to do it. So a simple correction is fairly straightforward. If you want to do something that's maybe potentially more accurate, then your algorithm has to get more complicated. We don't have an algorithm that does that. We'd be happy to include something. I think Libatomprobe gives you most of the basic tools you need if you just had X, Y time of flight to then turn that into an actual reconstruction. But we're not working on data. We're mostly working on data that's already been reconstructed. So I think there's a good opportunity there for working with Peter and Patrick, etc. To try and get that full reconstruction chain actually there as a basic tool that people can use. I think there's just not been the need for it at the moment.
We certainly have that available. The thing is, right now it's not in, like, we've really polished all of the scripts that we've put on the Libatomprobe toolbox. That's not really polished, but if you want to have it before, and I can give you voltage and ball correction tools. It's not very complicated to do voltage and ball corrections. It's not hard. It just needed to do it iteratively because the drift regions aren't field free. Yeah. We do have one Libatomprobe that is completely field free inside. Then it's completely trivial.
Okay.
I'll just piggyback a comment of Andy. I think one of the goals that we're trying to do with Libatomprobe is to make it sort of there are a lot of different modules. And so as Andy says, a lot of our focus has been on trying to do the modules that are important to us. So it's very difficult to know what's needed for the community. We need to really get a bit of feedback there about what people are using, what people need. There are other functionality within that. There is other functionality within that software, things like mesh processing, spectral analysis, working out background counts, doing things like ion identification, where it's not focused on POS files. So I think it's quite a horizontal library in terms of it covers lots of different things, but it's very needs driven. So you might find that it doesn't necessarily capture your need, but we'd definitely like to hear about what your need is and what we could incorporate there.